Dawn, Frida, and Bert live in a town where the streets are laid out in a grid system. So here's the grid. Dawn lives 3 blocks east of Descartes Avenue and 5 blocks north of Elm Street. Frida lives 7 blocks east of Descartes Avenue and 2 blocks north of Elm Street. Plot points to show the location of Dawn's house and Frida's house on the coordinate plane. Label each location with the student's name and the coordinates of the point. Okay, so let's start with Dawn living 3 blocks east of Descartes Avenue. So here's Descartes Avenue. Here's east, so somewhere along this line. Looks like on Euclid Avenue, right? 1, 2, 3. And 2 blocks, let's see, 5 blocks north of Elm Street. So here's Elm Street. So 5 blocks, 1, 2, 3, 4, 5. That's Oak Street. Okay, so here is Dawn's house. We're just going to label that with a D. And it said the coordinates of the point. So this point is 3, 5. Okay, now we need to plot Frida. She lives 7 blocks east of Descartes. 1, 2, 3, 4, 5, 6, 7. Right here at 7, right? And she lives 2 blocks north of Elm. So right here at 7, 2. So here's Frida at 7, 2. So name the streets that Dawn lives on. Okay, Dawn lives on Euclid and Oak. And Frida lives on Maple and Euler. Okay, so Bert lives at the intersection of the avenue that Dawn lives on and the street that Frida lives on. Okay, so intersection of where Frida lives plus Dawn. So Bert lives on a street that both Dawn and Frida live on, so that must be right here, right? Because Frida's lives on this street, Dawn lives on this street. Or it's possible, actually. Let's see, Bert lives at the intersection of the avenue. Oops, I did not pay attention to that. You got to pay attention to the avenues, right? So Bert lives on the same avenue as Dawn and on the same street as Frida, so that must be over here. Okay, so there's Bert. And Bert lives at 3, 2. So describe the location of Bert's house with respect to Descartes and Elm. So Bert lives 3 blocks east of Descartes and 2 blocks north of Elm, right? So how do the x and y coordinates of Bert's house compare to the x and y coordinates of Dawn and Frida's house? So you can answer that question in words yourself. Be sure to answer that question in words, but there's obviously something in common with both. Question number 4. Use Dawn and Bert's house coordinates to write and simplify an expression that represents the distance between their houses. Okay, explain what this means in terms of the problem situation. Okay, so we've got Dawn and Bert, and they're living 1, 2, 3 blocks from each other, and you can see that using the y coordinates, right? If you see the x coordinates are the same, but the y coordinates aren't, so that's like 5 minus 2, right? 3 blocks. So use their coordinates to write and simplify an expression that represents the distance between their houses, right? So if you take the 5, that's the y coordinate of Dawn, minus the y coordinate of Bert, that's 2, right? You get 3. So that means 3 blocks. They're 3 blocks apart. So now you can do the same thing with Bert and Frida's house to write and simplify an expression that represents the distance between their house and explain what it means in terms of the problem situation. Now, number 6, so make sure you do this for the independent study. All 3 friends are planning to meet at Dawn's house to hang out. Frida walks to Bert's house, and then Frida and Bert walk together to Dawn's house. So use the coordinates to write and simplify an expression that represents the total distance from Frida's to Bert's to Dawn's. So Frida goes from the 7th block to the 3rd block, right? And then she goes up from the second block to the fifth block, right? So she travels from the 7 to the 3rd. So that's how long it takes her to get to Bert's house. That's how many blocks. And then this goes down here. 7 to 3rd. And then from Bert's house to Dawn's, this is the distance, 5 minus 2, right? So distance to Bert's, from Bert's to Dawn's, distance from Frida's to Bert's. And then if you add those two together, if they walked those lengths, this would be how many blocks. So that's the coordinates, using the coordinates to write, and we simplified so simplifying it, that's 4 plus 3 equals 7. So how far in blocks does Frida walk? She walks 7 blocks, right? And if you draw the direct path from Dawn's house to Frida's house, so they want us to draw that direct path. And if Frida walks to Dawn's house on this path, how far in blocks does she walk? Okay, so we're supposed to draw the direct route. So if she draws a direct route from Frida to Dawn's, this is the direct route right here, right? Now this is a little bit different. If she walked to Bert's house first, she would have gone 4 blocks and then walked 3 blocks to Dawn's house, right? But if she walks straight, assuming she can, cut through the yards, assuming that she can just walk through the yards and go straight to Dawn's house, it's probably going to be faster, right? So let's come over here and draw that shape, right? We have this shape right here, and this is the direct path we're looking at. Now we know how long it is from here to here. We know that that's 4 blocks, and we know how long it is from here to here. We know that's 3 blocks, right? But the question is, how far is that right here if Frida were to walk exactly? Now, if you notice, we have a right triangle here, and anytime you have a right triangle with sides, you can use the Pythagorean theorem. And as a reminder, that's a squared plus b squared equals c squared. So this comes in handy a lot, this formula. We have one of the legs is 4, one of the legs is 3, so we can plug that in. 3 squared plus 4 squared equals c squared. That's the same thing as 9 plus 16 equals c squared, which is 25 equals c squared. And then to undo the squared, we're asking ourselves what number squared gives us 25? Or we could take the square root of both sides. So that's 5. If we square 5, we get 25. So this is 5. So Frida would walk 5 blocks, right? Now there are a couple other ways you could have determined this, right? We could have taken another sheet of paper and kind of marked off some blocks. 1, 2, 3, 4, 5, like this, 6, 7, 8. And we could have just kind of measured it. But if you notice, if you measure it, 1, 2, 3, 4, 5, right? It turns out to be the same. So there's actually several ways you could have done this to determine, oh, it's 5 blocks. You could use the Pythagorean theorem, or you could have just drawn yourself a little scale that you can move around and measure. So number 8 says, complete the summary of the steps that you took to determine the direct distance between Frida's house and Dawn's house. Let D be the direct distance between Dawn's house and Frida's house. So distance between Bert's house and Frida's house. Remember, Bert's house was so that was the 7 minus 3, right? And the distance between Dawn's house, so here is basically them showing you the steps of the Pythagorean theorem. So if you didn't use Pythagorean theorem before, they want to talk you through this, right? And then distance between Dawn's house and Bert's house is 5 minus 2. So that's the same thing as 4 squared, 3 squared, right? And we don't know the direct distance between Dawn and Frida's house, right? But let D be the direct distance between Dawn and Frida's house. Well, we said that it was 5, right? I'm not sure why. It should be 5 squared here. So I feel like they didn't do this problem quite right. The direct distance between this squared plus this squared should equal this squared, right? So let's just keep putting 5 squared here. So they should have a squared there. That's a mistake in the text. This should say 16 plus 9 equals 25. And then 16 plus 9, 25 equals 25, right? So this is just showing you why the Pythagorean theorem works, or a different way of talking you through the Pythagorean theorem. But I think probably doing it over this way makes more sense. Okay, so we're going to stop there. In the next video, we'll show you the next few problems.